Hi, in this video we are going to explore what an electromagnetic wave is. So first and foremost, it is a wave. So to understand it, we have to understand what waves are in general. Okay? So here I have an animation of a water wave. Okay? So here, how do we create water waves? Well, we simply vibrate the water so that you can create a wave pulse, right? And if we make the vibration constant, right? Here it's represented by a drop of the water. You propagate water waves. Okay? So that is key. How do we create a water wave? We simply do it by vibrating the water. Okay? Now, how about another type of wave? Like a sound wave. Okay? So I have here a speaker. How do we create a sound wave? We vibrate the cone so that it creates a sound pulse. And if we make the vibration constant here, you create the sound waves propagating out. Okay? Now we can also look at it from the perspective of the particles in the air. If we can see the particles in the air, these are the particles in the air. If we vibrate the cone, the vibration propagates outwards through the particles, and we call this phenomena the sound wave. Okay? So that is also another key. How do we create a sound wave? The same thing as how we created water waves, by vibrating, this time, the air particles. Okay? So for example, if you like pluck a string in your guitar, what you're actually doing is you're vibrating the string, and the string in turn vibrates the air particles, and so it propagates out. And so if you have a friend 1 meter away from you, that friend would hear the vibration, and your brain would interpret it as sound. Okay? So in a similar manner, what or how do we create an electromagnetic wave? Well, it's a wave, right? So it must be something similar to how water and sound waves are created. So it must be created by vibrating something. Okay? And what is that something? As it turns out, it has to do with electricity and with magnetism. Okay? Because it's, after all, it's an electromagnetic wave. As it turns out, an EM wave can be created by vibrating charged particles. Okay? So what do we mean by that? I have here another animation. Um, Here, this time, this is an FM station. This is an FM station similar to what we have in Hagna. And this is a household with a receiving antenna. This is the receiving antenna. This is the transmitting antenna. Now, if you're wondering how FM stations, AM stations broadcast their signal, it is this. They actually have a transmitting antenna, and in that transmitting antenna, they vibrate the electrons. And look at what happens when you vibrate the electrons. You actually create a wave that propagates outwards, and it's received by the receiver. And that wave is what? Yes, that is called the electromagnetic wave, because you just vibrated a charged particle, which is, in this case, an electron. So basically, an FM station has very complicated, complex circuitry, and its purpose is just to vibrate the electrons in its antenna so that electromagnetic waves can be broadcasted. Okay? Now, again, that's a very simplistic way to look at it, in a similar manner as we create water waves by vibrating water, and we create sound waves by vibrating air. We create electromagnetic waves by vibrating charged particles. So charged particles such as electrons, protons, and ions. Now, why exactly would vibrating a charged particle create an EM wave? That is what we will discuss next. But before we do that, obviously, we have to review, or we have to look at certain aspects about electricity and magnetism, because after all, it's an EM wave, electromagnetic wave. Okay? So let's take a look at first, here, a certain animation that involves electricity. So here you have a coil of wire, right? So this is just a wire that is coiled, looped 4 times, and then connected to a battery. So as you can see here, these blue dots here are the electrons. So as you can see, no electricity is flowing. There's no electricity inside, meaning the electrons are not flowing because the voltage of our battery is 0, right? But once the voltage is not 0, you would notice that the electrons are flowing around the coil. Okay, now mind you, this is a purely electrical setup. This is just a battery connected to a wire, electricity flows to the wire, and that's it. What's interesting is we can actually have a field meter. This field meter is a magnetic field meter, as you can read here. So it detects magnetism. And what's interesting is this: if you don't have electricity flowing, no magnetic field detected. But the moment you turn it on and the electricity is flowing, you detect a magnetic field, right? Crazy. What does that mean? That means that the coil actually became a magnet. Okay? So this is important. Electricity can create magnetic fields. Okay? And once we knew that, we wondered about the reverse. If electricity can create magnetism, can I have magnetism create electricity? Okay, and well, let's explore that. I have here a coil connected to a bulb. So if electricity is flowing here, the bulb should light up, right? But as of now, we don't see the effect of the magnet into the. You don't see any effect of the magnet to the electrons. But notice what happens when I move the magnet. Notice that when I move the magnet forward and backwards, the electrons in the coil flow and therefore create electricity and therefore light up the bulb. Okay? Now, what is happening here? What creates the electricity? Well, we can again show the field meter. And again, this field meter is a magnetic field meter, so it detects the magnetism of the magnet. Notice that if I have the magnet farther away, the magnetic field is weak. It's 0.12. But if it's closer, the magnetic field is stronger, which is 10. Right? So therefore, if we make the magnet move farther and closer and farther and closer and further and closer and further and closer, notice that the magnetic field value changes. Right? And notice another thing, the electrons flow. If the magnetic field is steady, the electrons do not flow. Okay? If the magnetic fields are changing, or if the magnetic field strength is changing, the electrons flow. So, a changing magnetic field actually creates electricity. Balik. A changing magnetic field creates electricity. In the similar manner as electricity creates magnetism, a changing magnetism creates electricity. Okay? But wait a minute. What is electricity? Electricity is just the flow of electrons. So therefore, the star should be the electron, not its movement, but it's the electron. So the electron is a charged particle. So let's examine what a charged particle is. When we look at magnets, a magnet class has what we call a magnetic field. This is the magnetic field of the magnet. And again, we can get a magnetic field meter. The closer you are to the magnet, the stronger the magnetic field is. The further you are, the weaker the magnetic field is, right? So scientists now realized, okay, if a magnet has a magnetic field, then we should also have an equivalent field for the electricity, which is an electric field. But since electricity is just flowing electrons, so we should focus on a particular charge, right? So this is what I'm going to show you next, which is this one. If I have an electron such as this one, I drop it here, you actually have an electric field. Okay? So this is different from a magnetic field. This is a field created by charges of electricity, right? So this is an electric field. And just like a magnetic field, the closer you are to the electron, the stronger the field is. The farther you are, the weaker the field is. Okay? But what is electricity? Electricity is just the flow of electrons. So what happens when an electron moves or flows? So I have an electron here, I will make it move towards the right. Notice what happens to the meter here. If I move the electrons to the right, notice that the electric field meter changes in value. So you have a changing electric field, right? Sounds familiar? Yes, that sounds familiar because that is similar to your changing magnetic field here, right? To create electricity, you have to create changing magnetic field. So therefore, when you have this, why it creates a magnetic field? It's actually because there's a changing electric field because the electrons are flowing. So therefore, we have this concept of kind of like a feedback loop where when you have a changing magnetic electric field, you actually create a changing magnetic field. But in turn, the changing magnetic field also creates a changing electric field. So you have this loop. Once you create a changing electric field, it creates a changing magnetic field. But once you create a changing magnetic field, you create this changing electric field. So how does that help us in understanding electromagnetic waves? This is the reason why electromagnetic waves are created. When you vibrate an electric charge, its electric field changes, therefore creating a changing magnetic field, and the changing magnetic field in turn creates a changing electric field. So the vibration never stops because this vibrates, the electric field vibrates, the magnetic field vibrates, the magnetic field vibrates, the electric field vibrates. So the vibration never stops. Okay? So that vibration becomes the electromagnetic wave. Okay? So let me pull up an illustration of how an electromagnetic field looks like. So this is it. This is an electromagnetic field. So you notice here the one marked with E is vibrating upwards and downwards. Upwards and downwards. That's the electric field. And then this B here, the one colored red, is the magnetic field. So it vibrates uh, perpendicular to it. So kind of like in a 3 dimension. So the electric field goes up and down in the y dimension. The magnetic field goes side to side in the x dimension, and both of them move forward in the z dimension. Okay, so it's 3 dimensional in nature. So essentially, that's what electromagnetic waves are. When you vibrate a charged particles, you create vibrating magnetic fields and electric fields that vibrate each other. And so they don't need any medium because the magnetic field is the one that vibrates the electric field, and the electric field is the one that vibrates the magnetic field. So therefore, it doesn't need any medium. That's why electromagnetic fields, as discussed in grade 7, electromagnetic waves rather, as discussed in grade 7, can propagate even in space where there is nothing there because they got each other's back. The electric field vibrates the magnetic field, and the magnetic field vibrates the electric field. Let me do that again. The magnetic field vibrates the electric field, and the electric field vibrates the magnetic field, and they don't need any other stuff to vibrate them. And in water waves, you need water because when you vibrate water, water waves are propagated. But at the end of the pool, of the swimming pool, when there's no water there, the water cannot propagate outward because there's no water, right? In space, if you strum a guitar in space, you won't hear a sound because there's no air to propagate. But electromagnetic waves are different because they don't need any medium. All they need is each other. The magnetic field just needs the electric field, and the electric field just needs the magnetic field. And so they propagate even without any medium present. Okay?